Hi, thank you for joining me on this channel. My name is Aamir and I share information about Google Sheets and spreadsheet on this channel. So in the last few videos, we had gone through charts and graphs. As you can see here, all of this is filled out. So now you should know how to make graphs on Google Sheets. Now we're going back to the formulas. So before the graphs, we have already done these formulas in blue. We're currently in the array section. If you want to go to any one of those formulas, you simply click on there, click on the link, and you can see those videos. Today I'll be covering two functions such as Linest and Logest, and that is basically checking if any data that you have, how close is it to the line and how close is it to the log function. So let's go to the array function. I click there, and if you scroll down, you will see around A122 these functions. So this is where I have made my notes. I have already given some data. So this is what the function is, Linest and Logest. And the information we need in this function is the y data, x data, the calculated b value, and verbose. And what do they all mean? So let's just go through some wording here. So Linus is your data linear or does it produce a straight line? Longest, does your data produce characteristics of a long function? And as for the variables, the known data y is requirement and is basically the known values of the response of a dependent variable. And then you also need to know the known data x, which is optional, and the calculated b, which is also optional, and that indicates whether the y-intercept should be calculated. The default value is true, which is what we want for the linear regression. And for the verbosal, which basically just means additional or precise or detailed, and this is also optional, and the default for this is false. So we'll look at these functions in more details. And before I go further, just want to show you that in ideal situation, a line graph looks like this in red. So it's just going straight from one side to another. And a default log graph looks something like this. So this is an ideal situation, this would look like, but not all data is like that because the data that you collect from surveys or somewhere else, it can have some errors, and we just want to check how close is it to a line graph or a log graph. So basically equation of our line is y equals mx plus b, m meaning the slope and b meaning the y-intercept. If I go up a little bit, you see the last function that I did, it had this. So if you want more information, you can come up and check. So now let's look at this data. So the equation of this right here is basically y equals 5x plus 100 plus some error. So the error is what I put in. I will show you what it is. And x is simple, it's just 1 to 5. And as for the y, I calculated based on this. So if you check here, the first number is x and times 5 plus 100, which is this equation. And the error is I have this other function called randbetween. I use this function a lot, and basically decide what you want to put. Pick a random number between 1 to 100 and just add it to this equation. And when this happens, and then I just drag this across and it just picks up all these values. And if you see the graph right here, this is what it will equal. So it's not exactly to the line, it's just a little bit higher or lower according to the straight line, and that will give an error. That will give an estimated straight line. The function, the way it works is I chose the Linus function here, And if I click in here, click at the question mark, it says what is the known data for y, which I select these data, and what is the known data for x, which I select this data. And then this is what it gives you. It gives you 5.3 and 102.1. And then so 5.3 is the slope and 102.1 is the intersection, the y-intersection. And if you want to see this data more details using this function right here, so in here I put y, x, and then I put true and true for both of them. So let's check what this is equal to. So this is the y function as I have selected above right here, and then x is this, and then I made sure that the calculated b is true, and then the additional detailed verbose is also true. So when I do enter, it gives me all of the data. And I'm not going to go into detail on this class, but if you're maybe a student or a statistics student, or if you need to know in other fields, this is the information that it will output. The way I have shown it here is it's just going from this side, and then it picks up this, and then it picks up this, and that's what I've done here. So 5.3, 102, 5.3, 102, and then it goes down here, 0.55, 1.82, and so on. It goes all the way down. So one of the values that I look in here is the r squared value, and that basically tells me how close is it to the line, to the ideal perfect line. How close is it? And this is 0.96, which means 96%. So 96%, it's close to an ideal perfect line. And in here, let me just delete this. So all I have done in here is just pick the y value. So initially when we're looking at it, we know this is value which is must. So I just put in the y value. I didn't put in any x value. I didn't put true for any of these. And I wanted to see does it still output something. And even though we did not put any x value, it still gave us the right value for the slope and y-intercept. So I just want to show you that it does work because all it needs is a y value. So similarly, log function works exactly the same way. And I have used this equation, y equals 3 log x. And basically, this is the function for x I put in, and this is function for y. And similarly, I put all of the y function and then all the x functions. It gave me the slope, it gave me the intercept. This is what it looks like, the graph for this function above. And if you guys want to know how I included all of this and all of this, you can check out my chart videos from before, or you can simply click here, click on the edit, go to customs, go to series, and you see the trend line, and I put log, and I show the equation and I show the r square value. So when you do that, it will show you all of this, and it'll also make it a log function like this. And similarly, just like the Linest, I chose additional information, and then it gave all of this. And also in here, I just put just the y function, and it gave me the slope as well as the intercept. The interesting thing here is that, so in this case, the slope and the intercept was the exact same, but in here is different. Here's a little bit off. This is 0.65 and 0.82. And I'm assuming because log is very precise in this case, that's why the first function is fine, but the second one is a bit off. So it needs the x value also to have the exact same value as this. And the last thing I wanted to show you is you can also have multiple x values and y values, just in case you have a data, let's say number of sales is this much, but the cost of it was this much, and some other values was this to produce the y. So I have done this with the Linest. I included the y function and then selected all of x, and then it gave me these values, and this is what they mean. This is what it looks like in an equation, in case you want to make this into an equation. And same thing I have done here, except this should be Logest. And same thing I've done here. So in here, I chose true and true for both of these. And then it gave me the additional information. And I listed in here what this information means. And same thing here, I chose the logest function. It gave me all of this information, and this is what it means. So this is just a quick overview of the Linest and Logest function, what they're used for, what they mean, and I hope you found this helpful. I look forward to going through all the functions with you, and I'm excited to teach you all of these until it's all finished. All right, thank you so much for your time. I hope you made it this far, and please share with your friends and family or anyone else who's interested. Okay, thank you so much. Have a great day.